Find the derivative of f of t equals 4t cubed times the sine of the square root of t. So f of t here is the product of two functions. We have the 4t cubed times the sine of the square root of t. We're definitely going to want to rewrite that square root of t as t to the first power second root, so t to the 1/2, to help with the derivative. Since we have a product of functions, the derivative will make use of the product rule. So the derivative f prime of t will be the derivative of the first, derivative of 4t cubed, bring the power down, 12t squared, times the second left alone, sine of t to the 1/2, plus the first left alone, 4t cubed, times the derivative of the second. The derivative of sine is cosine. Leave its inside alone, and now multiply by the derivative of the inside, which is a power rule, 1/2 t to the, bring down the power, and then subtract 1 from it. And then you multiply by the derivative of the inside of that power function to complete the chain rule, but the inside's just a t, the derivative of t is just a 1, and therefore we don't need to write it. So we have a 12t squared sine of t to the 1/2 can be rewritten as square root of t. We have a 4t cubed, and we have a cosine of t to the 1/2, also can be rewritten as square root of t. And then we have a 1/2 and t to the 1 minus 2, which is negative 1/2. Now at this point, I can move the constants together. Everything's multiplied, so that 1/2 can move together with the 4. And that t to the negative 1/2 can move together with that t cubed, because we will add the exponents in that case. So f prime of t will equal to 12t squared sine square root of t plus 4 times 1/2, which will be 4/2, and then we'll have t cubed times t to the negative 1/2 cosine square root of t. Now that 4 and the 2 will cancel down to give us a 2. And we have 12t squared sine of the square root of t plus 2 times, now we need to add those exponents, so I'm going to rewrite the power of 3 as 6/2. So I can add to the negative 1/2 and then cosine the square root of t. So we can multiply and combine those, and we add the exponents in that case. So f prime of t equals 12t squared sine square root of t plus 2t 6/2 minus 1/2, 6 minus 1, 5/2, so t to the 5/2, and then cosine square root of t. So there's the derivative f prime of t. It is possible to factor this a little further. There's a common factor with the constants. There's a 12 here and a 2 here, so we can factor out a constant of 2. So f prime of t will be 2 times 6t squared sine square root of t plus t to the 5/2, we took the 2 out, cosine square root of t. But we can actually factor out t as well here to a power. Now what we have here is t squared and t to the 5/2. 5/2 is a little bit bigger than 2, so the lower power is the t squared. That's the amount of t that we can factor, so it'll be a t squared that'll factor out. Now for the first term, that will remove all of it, so it'll be sine just the square root of t. For the second term, remember what we're doing is subtracting exponents, so what will be left for that second term will be t to the 5/2 minus 2. Whenever you factor, you're dividing, and dividing means subtracting exponents. So it'll be 5/2 minus 2. And then cosine of the square root of t. Now what we're going to do with that 2 is multiply it by 2 over 2 to get a common denominator. So f prime of t is now 2t squared times 6 sine square root of t plus t raised to the 5 halves minus 4 halves cosine square root of t, 2t squared times 6 sine square root of t plus t to the 5 minus 4, 1 half cosine square root of t. And the last thing we can do here is rewrite this as a square root of t. Everything else will remain the same. And there is our simplified version of the derivative f prime of t.